officially recording.
All right.
That's why I'm buying chicken.
So, tests are in, they're graded. If you're not happy with your score, you might want to come see me. So, you know, you're not in trouble yet. Come see me. Just, let's figure it out. Let's get through it. Let's kick some you know what on it next time. I think you're gonna find some comfort in today's. It's gonna be like, okay, dude, we're chill. Cool? That very first part of that unit is tougher. That quiz I made, usually your quizzes are worth like 70 or 80 points. That one was only worth
58.
How much?
58.
58.
Thank you for that.
So you got it good on that. All right. Who's not here? Where's Red? And where's Gypsy?
They were here. They're probably getting food for you.
Anna's gone.
How's the drawing, Mr. Stern?
Love it.
Eagles go.
All right. So let's talk about last time's homework. It was letter G. Letter G. And I asked you to do evens, right?
G.
Oh,
I did the whole.
Don't worry. It's not going to. Probably didn't hurt you. All right. What kind of questions did you come across? All of them good?
12.
12?
How do you even graph?
Tea table, buddy. All right, so number 12, that says P at X. P at X just means the same thing as F at X. Is this the right question?
Yeah.
Okay.
Mr. Look at us bonding up here together.
It's magical.
It is magical.
All right. So things that you should be able to recognize that this is actually this. Is that okay?
Yep.
So we want to think about where this what this graph doing. All right. Where's my starting point? What can I plug in for x to make the under the radical equal to 0? If I plug 4 in, if I plug 4 in for x, I get. I plug 4 in for x, I get 0 minus 5, so I get 0, negative 5. Okay? So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4, and 5. That's my starting point. So this shifted right. Now, before you say, well, there's a negative under the radical. Absolutely right, but where's the negative tagged to?
What?
Where's the negative under the radical? X. On X. It's not on a number, right? All right, so that means this right here means flip over y-axis. So originally this one, if that was positive, or that wasn't that way, it would go this way. Kind of curve up and going this way. But this one is going to curve and go this way. And there's other points I could find. You could say, well, how can I find out where it crosses the y-intercept? Well, that means you would just have to plug 0 in. If you plug 0 in, 4 minus 0 is 4. Square root of 4 is 2. 2 minus that is negative 3. So that's what that graph looks like. Okay? So it starts there at that blue dot, and it goes all the way to the left to negative infinity. So my domain of this graph, I'm coming from the entire left way, so negative infinity. In my x direction, I'm going to get all the way up to 4, and that's a square bracket, and we're done as far as the domain goes. If we figure out the range, what's my lowest value in the y direction that I'm at?
Negative 5.
Negative 5, so square bracket. And this graph, even though it's kind of like, doing that, it's actually growing to infinity as well. It just kind of advances faster to the left than it does up. That's done. Is that?
Wait,
that
so
yeah?
you do this by hand and not from optical calculator?
I would do it by hand.
Oh, okay.
Okay, so it states the domain range, square. Okay, we're done. Good? Yeah, buddy. Yeah, I'll have that by the end of next period. And you got Bubba. Yes, How did I get what? -3. Hang on, let me put this back in here. -3, where are we getting? Oh, so this is 0, 1, 2, 3, 4, and then it goes -1 here, -2, right? Keeps going. So if I plug 0 in, which is this, it'll find where it crosses that. So I plug it in. 4 minus 0, 2, 2 minus 3, -3. Basically, you have 2 points that it defines. You find your starting point, and then if you can find where it crosses the x-axis or the y-axis or another point, that's fine. All right. What else would you like to see off this?
We did 13.
You got it.
Bless you.
One more.
Bless you.
All clear. 13. Let's take a look at 13. Yes, you only had to do evens, but I won't hurt you to look at 13. Please, by all means, write this down for notes on your page. So we have this, x plus 2, and then plus 6. All right. So sometimes when we're just starting these out, it might be easier to think about, hey, what would y equal root x look like? Well, y equals root x will do is blue. And it kind of looks like this. That's the parent function. Is that okay? Does everyone agree that the function that's up there will be that kind of graph, but it'll look a little different? Yeah, we have a -3 out front. So that's different. We have a +2 underneath the radical. So that's going to be different. And then I have a +6. So let's do this one in green. Is that all right? So let's figure out. So that means up 6. That means left 2. That means flip over the x-axis and triple. Okay? Because there's just 3. Okay, let's figure out how to do that in a second. All right. So my starting point will be left 2. Good so far? Up 6. 1, 3, 4, 5, 6. That's my starting point. Maybe I'll make it a little easier to see. Is that okay? That's my starting point. It's a solid dot. Okay? So rather than going down 1, right 1, it's going to go down 1, right 3. Actually, it goes down 3. It's flipped over 1, 2, 3, and right 1. And then we can actually figure out where it crosses the y-axis. How? Plug 0 in for x. 0 plus 2, root 2. Root 2 is about 1.4. -3 times 1.4 is 4.8. -4.8. -4.8 plus 6. -4.8. Plus 6. 1.2-ish. Something like that. So that's what this graph looks like. Does it look a little different than the blue one? Yeah, it kind of flipped upside down, but it's the same kind of graph. So then let's talk about our domain. What's the furthest left that my graph is going? How much are we at? -2. 2, and it's going right to infinity. And then my range, the highest up I can go is 6. So where was it coming from? It was coming from negative infinity. It's coming from down here, up to negative infinity, and it goes all the way up to 6, square bracket, done. What else would you like to see out there? 10? 10's almost identical to this. Okay, so 10, if I made that a 2, and I made that a 5. So, choose an orange one to do it in. Let's do this purple. That's kind of fun. So we'll do the same thing. So I'm gonna go left 5, up 6 still. So rather than coming down 1 or coming down 3 and write 1, I'm going to come down 2 and write 1. Find where it crosses the y-axis, so plug 0 in, so I get 0 plus 5. Square root of 5 is 2 point something times -2, so -4 point something. So it's still about right there. And that's what this is number 5's answer. And then the domain on 5 would go, starts at -5, goes to infinity, range goes from -infinity to 6. That's it.
So to get like the y-intercept, you need to put 0 in as x.
And it's going to be a radical sometimes, so guesstimate it. Do you think it matters to me if you get between 1 and 2? Put a top somewhere between 1 and 2. You don't have to be official. If it comes out to a perfect square, perfect. If it doesn't, don't.
So then after it hits that, it just goes straight.
It's kind of a curve. It's like a slope.
Okay.
So it's kind of like you started at a 14er, and we're still here in Denver. Are we still going downhill if we go to Kansas? Yeah, keep going all the way to the Mississippi. It's going downhill until it gets to the Mississippi, and that's almost sea level.
Okay.
Does that make sense?
Yeah.
Okay. But then it theoretically it would keep going.
When do people actually use these? Like, I understand why people use.
I just gave it to you. Go from the Rockies to the Mississippi. Done.
Wait, then what
Drop
do
the
you do if it's a third root?
Third root. You have one right there?
Yeah, number 3.
3? Okay. So a third root. So let me ask you this with a third root. Can I have negative numbers under the third root?
No. Yes.
Yeah, like third root of -8 is -2, right? So negative numbers work. So I don't really have any restrictions on this. So let's graph what the parent function would look like, and I'll do the parent function y equals third root of x. So this just kind of does this. Looks like that.
Oh, it's one of these things.
What is this one doing then?
Going down to.
Yeah, so this point here, I'm going to go down to here, and then it's just kind of doing this.
So then if it's negative, it does the same thing? It just like switches?
If you had a negative out front, it would just like rotate. So this would be down here, this would be up here.
Like if it was negative x inside?
Negative x inside would actually make this go this way and this go that way. So the hard thing on seeing that on the parent function, it would be harder to see the difference between a negative out front and a negative at the x because it's just that kind of function, because it's continuous both ways. And then domain and range, negative to positive infinity on both, because it just keeps going. So third root, fifth root, seventh root, they all kind of look the same.
And then what do evens?
Evens start and go either right or left.
Okay.
So they have a starting point. All right, we good with those? Names on those. Pass those forward, please.
I wonder if it's still snowing. Probably.
Yep.
How's your day going, guys? Pretty good?
So you just put that away for later and just chill. You know where to find when you're all healed and do. Okay?
Ew. What'd you do?
It ran into a pole. It wasn't playing soccer. No, I didn't know.
Wait, what?
Need one more?
Did you just say that?
All right. Which row?
This row.
Oh. Keep goofing this row up.
Oh, wait, we have an extra.
Oh, never mind.
Where was the soccer field? There's a pole in the middle of it.
I'm so mad, Mr. Sue.
What'd I do?
That's what I didn't do.
What didn't you do?
I didn't do G.
Gee, man.
I didn't know we had it. I feel like that drawing is worth it though.
Yeah, it is.
Now we're in California.
I still think that's one of my best drawings yet.
I'm proud of you.
Will you save it?
Well, as long as I can. All right.
It's so funny.
So we're going to talk about how to add, subtract, multiply, and divide functions. Okay. This is a much easier thought process as long as you just realize how to do it. And then domains and interval notation. So the big thing on these, we're going to be having to find the domain and range of all of them. Yo, let's see ya. Man, you're all cold. He's snowy on you. All right. So let me ask a question here. Do I have a restriction on? Do I have a restriction on that x?
No. Yes?
No?
I don't want imaginary numbers, so do I have a restriction?
Yeah.
Yeah.
So my domain on this is going to go from 0, because I can have square root of 0. Do you agree?
To infinity.
To infinity. And then let's figure out my range. Well, if I plug 0 in, what do I get out? 0. Oh, I'm sorry.
You're good.
So my range, I would plug 0 in, and I get 0 out. And then if I plug numbers in, does this get bigger and bigger and bigger as I keep? Yep. Yeah, so it's 0 to infinity. So that's your most basic parent function of a radical with the domain and range. Okay. Do the restrictions apply to others? Yeah. If I had 4th root, 6th root, even roots, you're going to have restrictions on it. Okay, so we don't want to have imaginary numbers. We want everything to be a real number. It's fine if it's a radical that, doesn't have, that's not rational. So those are just a few of the things so far. Okay, move on. Yay. All right, so this one, do I have a restriction on this?
Yeah.
Well, what can x not be equal to?
Negative.
Oh, I can have negatives downstairs.
0.
I can't have 0. So on this one, I just have a singleton number that can't work. Every other number can work, but if I have 0 downstairs, it becomes an undefined term. This one, what about that?
That can't be.
Can't be what?
You can't have 3 on
3. Okay, so I have a singleton spot that it doesn't exist.
But then on the top, anything works.
Top, anything works. Even 0, -7 on top would still give me a 0 on top. 0 on top, totally fine.
So like
0 on bottom is the big no-no.
these ones, the only thing you're looking for is the ones that make it 0. Then let us know.
That's right.
Cool.
Yay! Right in there. Thanks, man.
Secret pile. Do you get
Secret
a
pile.
burrito or something?
Nah.
What?
Got me goodies, man. Love it. Thank you. All right. So does this make sense so far? Is everyone pretty legit? So how would I write the domain of this one? Is I would say the domain would go from -infinity to 0 and from 0 to infinity. So that's basically the way of writing your domain that you're saying, hey, I can't have 0. The domain of this one would go from -infinity to 3, and then from 3 to infinity. That's all it is. And that's just you saying, hey, I understand that every number works except for the 3. That's why there's rounded brackets at 3 both sides. Is that okay?
So is this like, you have to have like the and thing in the middle of this?
You can. Moving on. All right. Well, I think these are boxes I'm going to move. Yes. Okay, all real numbers. All real numbers greater than 5. These are just examples. All negative real numbers. All real numbers greater than or equal to 5, square bracket. All real numbers less than or equal to 4. And all real numbers except for 6. Okay, and that's basically what we had done on that last one. I don't know if I used 6 on it or not. That's it. Okay, so this is some prior knowledge. And it's just remember and recall. And again, domain and range is kind of an awkward thing, but I promise you, when you get to the calculus level, the better you have this down, the better things will be in calculus.
It's calculus.
And trust me, if you can make it through this class, you can make it through calculus. I mean, take pre-calc first. Don't be like, go from here to calc.
It's calculus just like a bunch of like graphs.
Calculus is an unbelievable class. And it's not just graphs. It's like you start looking and going, there's kind of some land of make-believe because you're like, hey, we're accelerating at this point, and then we are not accelerating at this point. Then you get to make the functions up after that. It's really cool.
Is that like
It's good. Trust me. I can't spoil the secrets.
are they gonna have word problems where it's
Heck
like,
yeah,
you have
everything's
the
a word problem in
train with
calculus.
An elevator on that train. How
No,
fast is the velocity
no,
of the
no,
elevator
no.
going?
No elevator, train, things. All right. So use interval notation to talk about each domain. So, whoa,
That's
wait.
what my sister had to do.
So negative to positive infinity. All non-negative real numbers. So non-negative, I would start at 0 and go to infinity. All non-negative real numbers. Why am I not including 0? 0 is not a signed number. Okay? All positive real numbers, same idea. Okay? All positive real numbers. So all non-negative real numbers and all positive, that's all the same. And all real numbers except for 3. So it's just kind of a repeat of what we just did.
Wait, shouldn't that be like 2? You can't have
Nope.
3.
The rounded bracket at 3 means I don't include it.
Oh, yeah. No.
Moving on. Pretty simple. All right. So don't let this freak you out. This just means, hey, we're going to go back to Algebra 1, but we're going to use functional notation saying, hey, we're adding things and subtracting things and multiplying things together. Multiplication is just FOIL or double distribute. And then division by polynomials is really cool. Now, you already knew how to do the long division or the synthetic division, which is awesome. But it's a great thing when you're dealing with these polynomials. You're not really having to do that. You're just saying, hey, where's the denominator restricted? Because you can't have that to be 0. Can I move on? You already have that all there? All right. So first one says, hey, we have function at x is equal to 2x, and function at x is equal to x plus 1. So we have f at x and g at x. Okay? Find each. So if I want to add them together, I'm going to get 2x plus x plus 1 equals 3x plus 1. Done. Is there any restrictions on this problem at all? Was there any restrictions up above?
Why does it equal 3x plus 1?
Because I have 2x and 1x, which is 3x.
Oh.
So just so you know this, the domain is negative to positive infinity for both of those. The range is also negative to positive infinity on my originals, both those originals. So that's something where, so right now both of those equations have 0 restrictions as they sit. Does that make sense if I say that information?
Yeah.
Means any number I want to plug in is going to work. And then I have this second one. Now here's where things start getting goofy, and this is where sometimes Algebra 1 kids have a hard time with this. Why did I put x plus 1 in parentheses? What am I doing to x plus 1?
You're making it negative.
I'm subtracting everything. So this is going to change to this. Agree?
Mm-hmm.
Which then becomes this, x minus 1, and there's my answer. Okay, so the big mistake that takes place in math is you forget to distribute your negative across the parentheses. All right? And then it says now use interval notation to state the domain for each problem above. Well, originally, my domain and range were not restricted. If those weren't restricted, does this look like it's restricted? Do I have an x in the denominator or x under a radical at all? Nope. So my domain and range are still negative to positive infinity. That should be a negative infinity, trying at least. And then this one, same idea. This is still domain, negative, positive infinity, range, negative to positive infinity, meaning I plug numbers in, I get numbers out, nothing really changes. Good? Move on? All right. So now, what does number 3 mean in your opinion? So before I start, do you still agree that the domain and the range are any numbers? So the x values and the y values, the inputs and the outputs are all any numbers I want. So what am I doing on number 3? What does this mean? What does that dot mean? Multiplication. So I got 2x times x minus 1, or x plus 1. Distribute, so I get 2x squared plus 1. Okay, now we are going to start seeing a restriction. Can I plug anything I want in for x and get something out?
Yeah.
So domain is definitely staying good. Range is goofed up now. Why? What happens if I plug a negative number into 2x squared plus 1? What does the negative number become? Positive. If I plug a positive number in, what does x still become? Positive. Are any negative numbers going to exist on this problem? Can I make this problem 0?
No. Yeah.
I can plug 0 in, can't I?
Yeah. You'll
So-
get 1.
Which is great, but I get
No.
I get what? I get what?
1.
1. So my range is going to go from 1 to infinity. Now, think about this. This is a parabola that opens up. Agreed?
Yeah.
My vertex on this one is 0, comma, 1. It's a parabola that opens up like this.
But then,
Do you see how the range
Yes,
just
that makes
became
sense.
restricted?
yeah.
Because I actually changed dimensions on this problem. When I say change dimensions, I mean I changed from a length to an area. So I went from a length to a length and width. When I multiplied and I increased it, this is really weird, wacky stuff as you progress further in math. Because as you start multiplying x's and more x's together, the more x's you multiply together, the higher dimension you get to. And I'm talking length, width, height, and then it keeps going. And I just want you to start fathoming that. No, I'm not going to sit there and classify every dimension for you, but you can have nth dimensions mathematically. Okay? Yeah.
So when you're distributing the 2x over, wouldn't it be 2x squared plus 2x?
It sure would. What does that mean then?
2 commas.
Hang on. I made an error. Thank you. So hang on. This has got to be modified. Hang on. Can I still get negative answers out?
Yeah. Actually, no.
Is it still a parabola?
Yeah. It's
So the vertex of this parabola would be negative b over 2a. So that's going to be negative 1. Plug negative 1 back in. That gives me 2 minus 2. Oh, 0 does work. We can start at 0. So this parabola actually does this. I'm sorry about that. And that's supposed to be negative 1. Oh, thank you for catching that. I didn't go too much further. Good deal. All right. Good. So slight little error, but I think we caught it in time, I hope. If it destroys you for the rest of your life, I apologize. All right, dividing them. First thing I'm going to recognize is this. Oh, wait. My f at x is this. My f at x is 2x, right? My g at x is x plus 1.
You can.
What number would make the denominator 0?
Negative 1.
Negative 1. So my domain is going to go from negative infinity to negative 1, rounded bracket, negative 1 to infinity. And I'm just going to stop on the domain on that one. I'm not too worried about the range. Does everyone see why -1 won't work on this one?
Yeah, because otherwise you'll have a 0.
0 on downstairs, and that's like this big bad thing. Those of you exploratory people on your calculators, when you divide it by 0 as a little kid, you're going, look, Ma, it's error. All right. So before I start this problem, x to the 4th power is the same thing as 4 through to x. Do you agree? So I just want to clarify that this is the same thing as the 4 through to x. Is that okay? Okay, so that's converting from exponent form to radical form, right? All right, so domain, let's just look at the domain. We just want a domain right now. Yep, we're going to just take care of the domain. Is there anything between these that is restricted? 3x, I can plug anything I want in. Agreed? So the domain here is negative, positive infinity. What's the domain here? Can I have the 4th root of a negative? No. Can I have the 3rd root of a negative? Yeah, so 3rd root's not restricted. 4th root's restricted. So I can have my domain here 0 to infinity. So that's my domain. So my domain is restricted on the second problem. So my entire problem has to be restricted. All right, so I'm going to multiply these together. So I'm going to go 3x times x to the 1/4 power. Hey, I have like bases. What should I do with the exponent? So like, dude, there's no exponent on the x. Yeah, it's 1. So that's x to the what?
5/4 power.
3x to the 5/4 power. So would my radical here still be 4th root if I put this back?
Yeah.
Yeah, so this would become,
parentheses 5.
yeah, this becomes 3/4 root of x raised to the 5th. Okay, let me ask you this. If I plug a number in, if I do 5th power first, would it change a negative to a positive? Well, negative, 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 negative. No, it stays negative, right? So can I have a negative answer, or can I have a negative x value on this problem?
Yeah.
No, I can't. Okay, 0 is still the smallest, so my domain is still the same, being 0 to infinity. Okay? And then here we're going to get a little dorkier. This is going to be 3x over x to the 1/4 power. Would tug of war happen?
Yes.
Mm-hmm.
It's the same base.
That's 4/4, right?
Yeah.
Tug of war top wins by
3/4.
3/4. Okay, so that's still 4th root of x. Agreed?
Yeah.
Okay, you got to be really careful on this problem. If I plug in 0, will it work with 3x to the 3/4? Should.
Plug in 0?
Would 0 work still?
Yeah.
Okay, but here I have a little bit of concern. What do I have down here? I have an x. X is a denominator in this case. So can this problem start at 0 and include 0?
No.
No. So watch how my domain is going to change. Let's see if you guys follow this. It's not a square bracket any longer, is it?
No.
Can you all see that it's a big rounded bracket? I wanted you to see that square versus rounded. Okay? You see how the domain now became even more restricted as I progressed through the problem? Can I move on? Blessing you. Blessing you again. All right. Composition of function. Now, before I start composition of a function, let me talk to my females in here, because I know females tend to like to shop a little bit more. I'm not trying to be sexist, but y'all females like to go shopping a little bit more than males.
I do.
No.
Okay.
Big
Yeah. I mean, I see some of the guys in here, they have like 3 t-shirts that they go through life, and they have the same pair of tennis shoes they've had since they've been freshmen.
Yeah.
And the girls are always dressed for the nines, which is wonderful. So, and trust me, I have 2 daughters. I have 2 daughters and a wife. Where does my paycheck go? It goes to their wardrobe, except for my shoes, because I got more shoes than everyone. So,
Oh, you're a shoe guy.
I have a problem with shoes. Yes.
Big shoe guy.
All right. So now, have you ever been walking through a store? And I don't know if some of the guys would say that in here, but I think some of the girls. Have you ever seen like a tag saying, take an extra 15% off the lowest marked price?
Yeah.
Or take another 30% off already the reduced 20% on your item? That is a composition of a function. Okay? That means you're taking a certain amount off, and then you're taking another certain amount off, because you're doing a percent of a percent. Okay? That's where this kind of falls in. Now, this isn't, we're not teaching this so you can go through and shop in life. But this means I'm plugging a function into a function. Okay? And this is read as fg of f.
What? Excuse me?
Fg of x.
There we go.
So sometimes we call this fog. Okay? So this is where we have to start being careful, saying we need to find the domain of our original functions first, and then plug it in, and then it could be restricted. I can't make my domain less restricted than my originals had. So let's see what that means as we progress. No, that's not going to help us. So I'm just moving off that. All right, ready? Okay. Eyes up here. See if I can do this the best way possible. Okay, I'm going to make this one yellow. Is that okay? I'm going to make this one. Can you see that okay? Okay, anyone justify it? I have 2 different color highlights up there. Okay, so the very first problem says I want fg of x. So that means I'm going to take g of x, which is yellow, and I'm going to plug it in to the purple. Okay, watch. It's not that hard to do. Visually, it's going to work. So I'm going to take this yellow. I'm going to take this yellow part right here and plug it in for this x. So I get 3 parentheses 2x minus 1 to the negative 1. Let me stop there for a second. Take a look what I just did. What did I replace on the first problem? I replaced x. What did I put in for x?
2x minus 1.
2x minus 1. Does that 2x minus 1 become raised to an exponent?
Yes.
What exponent is that?
-1.
Negative 1. So what does the 2x minus 1 want to do?
Go on the bottom.
Go on the bottom. Good. All right, so I get 3 over 2x minus 1 on bottom. All right, let's go back here. Let's take a look. Think about our domain. Our domain of this one is just negative to positive infinity. That's just happy. Domain of this one, I have 3x to the negative 1, which is the same thing as 3 over x. So how is my domain restricted here? What can't x equal?
0.
0. Good. Okay? So, I have to now think about this. Originally, 0 didn't work. Agree? Agree?
Yeah.
What would make my denominator 0 on this one?
1/2.
1/2. Awesome. Okay, hang on. Pencils down, eyes up here. So this right here, 1/2 is not equal to x. Okay, hang on. Was my domain restricted on my first one?
No.
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 Yes.
3 over x, right? On my original functions, it was restricted.
Oh, yeah.
So it couldn't equal 0 there. Now it can't equal 1/2. Okay? Ready?
Yes.
So I'm going to go from negative infinity to 0,
To 1/2.
from 0 to 1/2, from 1/2 to infinity. That's my domain.
Okay.
So, did my domain increase on the number of things that it couldn't be?
Yeah.
Yeah.
Does that make sense? So it went from having only one number that didn't work to having 2 numbers. 0 and 1/2 don't work. So it breaks it up into 3 signs. Okay? Same idea here. Same idea here. I'm going to take f at x. So I'm going to take 3x minus 1, plug it in for x. So I have 2 parentheses minus 1. I had an x here originally in my yellow. What goes here? 3x negative 1, which is the same thing as 2 over 3, or excuse me, 2 times 3 over x minus 1. Does this still have a 0 restriction?
Yes.
Yeah, so my domain stayed the same here.
Wait, so you just plug in 0 for x?
Well, 0 just, my variable can equal anything else except for 0. That's why I had to write it. Okay, and this will be my last one. This is kind of goofy. I want to plug this into itself. So I'm going to take 3x minus 1, 3x to the negative 1, and plug it in for itself. So I have 3.
What?
So I have the 3x minus 1 right here. That's my f at x. And then I have 3 blank. That's where I plugged it into negative 1. So then that means I'm going to have take care of the inside. Agree?
Yes.
What does that negative 1 do to the outside now?
Flips it.
Flips it. That's going to give me 3 times x over 3, which then cancels, which then gives me x. But was my original stuff restricted?
Yes.
As x sits here right now, it says, dude, anything works. But my original had a restriction having 0. So my domain has to have the same restriction.
Okay, that makes sense.
Okay? Is there more problems?
Yeah.
Holy cow. So this is just plug it in. Okay. Oh, hey, look. I told you. It's there. That's it. Okay. So I think it's a 3-day weekend, so I can give you like 5 pages of homework, right?
No.
Because I'm that teacher, aren't
What
I?
about just no homework?
Yeah.
Extra credit instead of
just like
homework.
the front page. Let's see.
What do we say we do? Worksheet 8H. And let's do every other even. So for those of you that find this hard, you do number 2, you skip number 4, you do number 6, you skip number 8, you do number 10, you skip number 12, etc. Got it? Every other even. Does that make sense? Hey, so I gotta tell you guys, dude, we had our band practice this morning.
Yeah.
You should hear We Will Rock You, how we're coming in on it. It is going to be like, it's going to be crazy.
Do we have assembly today?
No. So February 7th is the talent show. That's a Thursday night. I'm expecting y'all to be there. And then February 8th, right before this period, we have an assembly. Make sure you have your food early. Get to the assembly because you want to be part of this.
Is 5th period assembly?
3rd period. Go to 1st period, 2nd period, go to the assembly, go to 3rd period, go to 4th period.
I'll go.